Now that we know what polynomials are, let's take a look at some operations we can do using polynomials. So in these notes, we're going to look at adding and subtracting polynomials, and also multiplying polynomials by a monomial. So just to get something clear, when we talk about polynomial operations, we are talking about simplifying polynomials. So to simplify an expression is to rewrite it without parentheses or negative exponents. We want to do all the operations we possibly can and write it in simplest terms. This is different than solving. Solving is what you do to an equation to find the answer. And so you can simplify an equation before you solve it, but we're not solving these polynomials because we're not finding a value for x or y or whatever. We're just simplifying the expression as much as we can. We are reducing it to its lowest terms. Some things to remember for these notes are the distributive property and how to combine like terms. Remember, you can only add and subtract the coefficients together on terms that have the same exponents with the same variables with the same exponents. But best way to do this is just to practice, so let's look at some examples. So it says perform the indicated operations to simplify each expression. So something you want to be careful of, and the first one is a great example of this, is when you are subtracting polynomials, you might end up with negatives. But remember, you're going to subtract each of these terms, not just the first one. So you're kind of distributing this negative sign to all of these and then adding. But if you just think of it as subtracting and go term by term, you should be okay. Another strategy is to write the second polynomial underneath the first one, lining up like terms like that, and then subtracting this way. And this is similar to what we did with elimination when we solved systems. We lined them up vertically and added to cancel things out. Very similar process, just line up the terms and add or subtract. I like to just go through and subtract like terms without that because I don't like to rewrite the expression. I like to do as little of that as possible. So that is definitely an option, but sometimes if you look at example C or D, you've got different numbers of terms, and so it can get a little challenging to line them up correctly if you're doing it vertically. So what I like to do is just go through my two polynomials and start with the highest degree terms and satisfy those first, and that way my answer will already be in standard form when I'm done. So first let's start with the x squared term, so 4x squared, and remember we're subtracting 2x squared. Well, that's 2x squared. 4 minus 2 is 2, and just leave the variable and the exponent alone. Okay, and then we've got negative 5x minus 3x. So that's a negative 5 minus 3, which is negative 8x. So be careful. Our inclination is to just add, negative 5 and 3, that's negative 2. But we are subtracting. Negative 5 minus 3 is negative 8. And then finally, we have 6 minus negative 1. 6 minus negative 1 is 7, so plus 7 there. So really just be careful about your negatives, especially if you're subtracting polynomials. Make sure you are actually subtracting. Use a calculator if you're not sure. All right, so that's how these work. Let's try the rest. The next one is addition. So we have 6x squared minus 7x plus 8, all added to negative 4x squared plus 9x minus 5. So 6x squared plus negative 4x squared, that's 2x squared. Negative 7x plus 9x, that's 2x. And then 8 plus negative 5, that is 3. So again, just combining like terms here essentially is what we are doing. Let's look at the next one. Now here we're subtracting, but our first polynomial doesn't have the x squared term in it. So what we're really doing here is subtracting that from 0, a 0x squared minus 2x squared. or just apply the negative to it. So you have negative 2x squared will be our leading coefficient there. Something that can be helpful is if you cross out the terms as you do the operation. That way you know what you've already done. So next we have 4x minus 8x, that's negative 4x. And then 2 minus negative 3, which is 2 plus 3, which is 5. So negative 2x squared minus 4x plus 5. Let's look at the next one. We are adding here. So again, be careful because sometimes if you start out with whatever terms you have in the first one, you might, not be in standard form for the final answer. So if we look through here, I see I've got a 6a cubed, and it's the only a cubed there. We are adding, so it's going to stay positive. So we have 6a cubed. And then let's move on to a squared. 8a squared plus negative 3a squared, that is 5a squared. And then there is an a here, but not on the first one, so that's fine. 0 plus 1a is still 1a, so plus a. And then 4 plus negative 2, that's 2. So again, just be careful about your negatives and which terms you have. If you were going to line this up vertically, it would look something like this. I'm going to write the bigger one first just because then you'll be able to see. We have 8a squared plus 4. It would look like this. We're adding those together. So there's kind of a 0a cubed and a 0a placeholders there that so you just bring this down and so on. So vertical is an option, but horizontal works just as well, and then you don't have to rewrite the problem if you don't want to. But it is an option. You can do it, and it does work. And if it's easier for you to visualize how the problem is working, go for it. All right, now let's look at multiplying by a monomial. So this is really just the distributive property. So we're going to take this 3x here and distribute it to each term inside the trinomial here. So 3x times negative 2x squared is negative 6x cubed, because x times x squared is x cubed. 3x times negative 4x is negative 12x squared. And 3x times 6, it's plus 18x. One thing to point out here, just don't forget to increase the exponents, right? When you multiply powers, add the exponents. So don't forget to do that. Example F is just written backwards. We're still distributing the 2n squared in through that. So 2n squared times n squared is 2n to the 4th. 2n squared times 4n, that's going to be 8n to the 3rd. And 2n squared times negative 6 is negative 12n squared. Let's keep going. Here we're simply multiplying a 5 into there. So that's 5f to the 5th minus 10f to the 3rd plus 5f squared minus 5f. Just add a 5 to the front of those empty, if there's no coefficient, just put a 5 there. 5 times 1 is 5. Obviously multiply the coefficients by 5 if there is one. Example H kind of puts these two things together. So first we're going to distribute here, watching out for that negative, and then we will combine like terms if possible. So 3m times 5n is 15m squared. 3m times negative 4 is negative 12m. Negative m squared times m is negative m to the 3rd. And negative m squared times 3 is negative 3m squared. And then you want to check for like terms. We've got a 15m squared and a negative 3m squared. And while we're at it, we might as well put this in standard form. So our first term is going to be the biggest degree. That's that negative m cubed. Next comes our m squared term. So 15m squared minus 3m squared is 12m squared. We've done that, and that. Now we've just got minus 12m, and we're done. Okay, so that's the basics of our operations here, adding, subtracting, multiplying by a monomial. We are obviously going to use this in in other things. For example, solving equations, which we'll do right now. So we're going to solve the following equations knowing what we just did to help us. So first we'll simplify as much as we can. So we've got x times 2x plus 3 plus 20 equals 2x times x minus 3. So let's go ahead and distribute here, distribute here. So 2x squared plus 3x plus 20 equals 2x squared minus 6x. It's going to be very helpful when you're solving equations or simplifying polynomials that you keep your work very neat. You want to line up all these things together. That way you can really see what you've done and where you're going next. So now let's bring some of these things together. Obviously, when you solve an equation, you want to get all your variables to one side and your constants to the other. So let's go ahead and subtract 2x squared. That's actually going to cancel completely out here. So let's keep going. Let's subtract the 3x. So we end up with 20 equals negative 9x. And then we'll just divide by negative 9, which will give us a fraction. That's okay. So x is going to equal negative 20 over 9 here, which I'm fine with. But if you don't like improper fractions, you could go ahead and say negative 2 and 2/9. All right, 9 goes into 20 two times with 2 left over. Or it's like negative 2.2 repeating, if you like that better. Let's go on to example B. Let's distribute this 3, and that's it. So 3y minus 6 plus 2y equals 4y plus 14. So first we can combine these. So that's 5y minus 6 equals 4y plus 14. Now we've got to bring our y's together, so we'll subtract 4y. And I'll go ahead and add the 6 because I'm going to do that eventually anyway. So we end up with 1y equals 20. A little easier there at the end on this one. So knowing how to simplify polynomials will definitely help you solve these more complicated equations, especially as we move on through this unit and we get to solving quadratics.